Greetings. My name is Marina Molchanova. I am a PhD student of the Khmelnytsky National University, and I want to tell you about our research, which is devoted to detection of web propaganda patterns by transformer neural networks, improving efficiently via dataset balancing. In today, information media manipulative contents plays an important role in the formation of thought, political views, and social behavior. Social networks have become a key space for expanding information, while at the same time becoming a tool for manipulative infusion. Therefore, it's very important to identify such propaganda patterns in web content in a timely manner. The importance of the study is confirmed by the correlation with the Sustainable Development Goals. Therefore, this study is relevant and aims to eliminate this drawback by analyzing the influence of the number of text without propaganda patterns on the effectiveness of transformer models. In particular, the study aims to determine the optimal ratio between text with propaganda patterns and natural text, improving the models generalizably and reducing their bias. The main paper contribution is a created methodology that includes method for balancing the dataset, method for fine-tuning individual binary neural network models to detect propaganda patterns, and a method for detecting web propaganda patterns. The methodology consists of performing three consecutive methods that allow detection propaganda pattern in web content. The study used a dataset from UNLP 2025, in which the data is marked at the fragment level and consists of 10 classes. The first method is a method for dataset balancing. Is designed to transform the general set of data in the in-part dataset into two datasets. It's training and validation, which will allow to increase the accuracy of determining propaganda patterns in web texts. In addition to the training dataset, a validation dataset is constructed which consists equal of all types of web propaganda patterns and text without propaganda. This allows determining whether the model does not confuse patterns with each other and whether it's able to detect them independently of each other, which is critical important for the multi-label classification problem. Accordingly, the result of the method of dataset balancing will be two dataset, its training and validation. To investigate the impact of the balancing of the training sample on the detect of web propaganda patterns using a set of individually binary neural network models, it's necessary to first present a method for obtain a typical individually binary neural network model for detection typical propaganda patterns. As a pre-trained model, the use of BERT-like architectures is proposed. Thus, this model can be applied to the analysis of Ukrainian text, even in the absence of large volume of markup data. After forming dataset and training a set of individual binary neural network models, detection of web propaganda patterns occurs. On step one, preprocessing of web content for analysis occurs, which includes of splitting into sentence, after which tokenization and performed. Step two, performed web content labeling by each of a binary neural network. Each sentence is evaluated separately by each of neural network, and if the output value of the neural network model for sentence excite the given threshold, propaganda patterns is considered to be manifested in sentence. Accordingly, each sentence will be given a subset of the element of the set propaganda patterns. At step 3, the formation of output view takes place, which perform it according to the rules. If there are already manifestation of other propaganda patterns for sentence, then such propaganda patterns are considered manifested in the text. However, the maximum value will be displayed with highlighting. If there are manipulative sentences with the propaganda patterns, the overall score of the manifestation in web content for analysis is calculated as the arithmetical mean. In accordance with the purpose of research, problem of improving efficiently via dataset balancing arises, which can be mathematically represented as the problem of maximization of the F1 matrix. The solution of the optimized problem will be carried out experimentally, changing the percent of non-propaganda text in the training dataset from 10% to 70% instead of 20%. For the experimental part, specialized software was created. After filling the training dataset using the method for dataset balancing, dataset where obtains the quantities distribution of which are given in table. In the presented result of testing models for detection manipulation propaganda pattern on the test sample, which different percentage for text without manipulation, one can observe a clear trend toward improving the performance of model, which an increase in the value of the parameter m. The analysis of the data from table indicates the ability of neural network models to remember, and here naturally, as in the previous table, there is a tendency for matrix to increase, which increase parameter m. However, the metric calculated of the training data allow us to access how well the model remembers this data, but do not give a complete picture of its ability to generalize new information. According to the table, at the parameter m equals 30%, this metric demonstration a higher result. Accordingly, while neural networks show a tendency to better distinct propaganda patterns at higher values of m during training, testing on balancing validation set refuse the hypothesis that the higher the resolution of the training data, the better the generalized ability of the neural network models. Compression of fine-tuned model of BERT and Roberta architecture on validation dataset by accuracy metric. The best average result of accuracy metric is 0.733 for the Roberta neural network and 0.704 for the BERT architecture. It's a 30% parameter m. There are compression of fine-tuned model of BERT and Roberta architecture on validation dataset by F1 matrix. The comparison with analogies is carried out in this table, and for the purity of the comparison of the development approach and existing analogies, the F1 value was taken specifically on the validation data. Accordingly, the highest F1 indicate for the Roberta architecture at M equals 30%. This for the task of improving the efficiently of detecting propaganda patterns in web text using transform neural networks, thought optimizing the balancing of the dataset has been fully implemented and experimentally proven. The paper proposed a methodology that includes a method for fine-tuning individually binary neural network models for detection propaganda patterns, method for balancing the data set, and a method for detection web propaganda patterns. The use of the proposed methodology allow it achieving in efficiently increase of 0.1 in terms of F1 metric when the detection propaganda patterns in web text using transform neural network thought optimize dataset balancing. The proposed methodology has limitation. This study uses a sentence-level approach. This may affect the quality of detection propaganda patterns, which may operate at the level of propaganda of even entire text rather than indicate sentence. Also, a single sentence may be neutral it itself, but it is context of propaganda text. Its meaning changes. This issue will be addressed in further research. There are also limitations at the data source level. The manual labeling used in the dataset may contain subjective judgment, which affect the training of this model. So, thank you for your attention.